And we continue with a talk from ZX Spectrum to Blazor, emulating a ZX Spectrum with .NET 7 and Blazor from Jimmy Engström. Jimmy has been developing even since he was 7 years old and got his first computer. He is the author of Web Development with Blazor and the co-host of Coding After Work podcast and stream. His passion for the .NET industry and community has taken him around the world speaking about development. Microsoft has recognized his passion by awarding him the Microsoft Most Valuable Professional Award 9 years in a row. Enjoy the talk.
Heroes and villains always have an origin story. Now, I don't want to say that I'm a hero or a villain, but this is my origin story. While making this presentation, I saw that almost anything in my life can be connected to the ZX Spectrum. So this became a more personal presentation than I first expected it to be. I will take you on a journey, my journey, from the 80s till today. But we will start with a bit of history. This presentation starts at 1980. January of 1980, the Sinclair ZX80 was released. It was released and it was available in the UK for less than £100. The same year, the VIC-20 and the TRS-80 came out as well. In 1981, the ZX81 came out. It was £50 as a kit, or you can get it for £70 as a pre-built machine. In April of 1982, the Sinclair ZX Spectrum was released in Europe, and this was the best-selling British computer. It sold about 5 million devices. In August, Commodore 64 came out, and it has sold for around 13 to 17 million devices. The C64 was the second most popular computer in the UK. Now, what is really cool with the ZX Spectrum is that it has clones all over the world. It has 5 official clones and more than 70 unofficial clones. So if we take the clones plus the officials, we will get over 13 million sold devices. Which brings us to 1985. Now, the second most important thing that happened to me in 1985 was that I saw Empire Strikes Back. The really annoying thing was that I have already seen Return of the Jedi. So let me introduce the new way of watching Star Wars, the Jimmy way. You will see 4, 6, 5. It was kind of, yeah, let's not go into that one. But that was also the year my parents got me my first computer. And you probably guessed it, it was a ZX Spectrum. Now, I remember that my parents bought it and my brother brought it home. I connected everything, and the first thing I did was that I typed 10 print Jimmy, 20 go to 10. This was my code. I made the computer do things. And this was a very defining moment for me, because this was the moment when I realized and I decided that I wanted to become a developer. Now, back then, you didn't bring out the camera to take pictures of everyday things or whatever you had for dinner. So this is the only image I found with me and a ZX Spectrum from around that time period. And as you may or may not see, that is a black and white TV. And the really, really cool thing with the ZX Spectrum was that it has 15 different colors. It was one of the first home computers that had all of these colors. But I had 15 shades of gray. And you can see my sister sitting there beside me as well. But here's where I come in to the story. My name is Jimmy, and I'm a Microsoft MVP. I've been running Blazor in production since it came out, but we will come back to Blazor in a couple of years. Now back then, we didn't have the internet. We had books containing code. And this book, for example, was translated into many different languages. We also had magazines that we could buy containing a lot of code. So basically what you did was that you took the book and you started typing the code into your machine. I mean, this one is pretty easy to understand, but there are others that was a whole lot more difficult to understand when you were just typing it in. Imagine that this is kinda like the 80s GitHub. This was how we source controlled things back then. My brother was working for a Swedish newspaper called Engström. He did both code and he reviewed games and stuff like that in the daily press. We also had like community radio that was broadcasting games or programs over the air. So I would argue that the community radio broadcasting was that time's Pirate Bay. Now, why am I talking about this? Well, it kind of proves how mainstream the ZX Spectrum was. It was in the daily press. It was in radio stations and stuff like that. It was a huge machine here in Sweden. Now, the year passed and I got a ZX Spectrum 128 or ZX Spectrum Plus. I got a Commodore 64. I got a Commodore Amiga, followed by a PC. Now, I was pretty interested in emulation, and one of my first web pages that I created was about emulation. Now, I can't believe I'm actually going to show you this, but this was that page. And if you look over there, apparently, I thought that Microsoft front page, this is something to be proud of. I want to show this off. I made this in front page. Now, despite all of this, I actually landed my first job as a web developer in 1999, working with ASP. Now, I had a huge interest in emulation, mostly Amiga at that point, and when the Xbox came out in 2002, the idea of emulation kind of came into my mind again. So I thought maybe I can build an emulator for the ZX Spectrum for the original Xbox. Now, there were a couple of problems here. The first one was that I didn't know C++. But then I found an emulator called Pocket Clive. That was a port of another ZX Spectrum emulator called Fuse. Now, the nice thing was that Pocket Clive was written by a Swede, so I kind of figured out how to contact him, and he helped me out what I needed to look at. So he helped me to figure out what I needed, and more importantly, what I didn't need. Now, I knew enough C++, so I actually got it working. This is a screenshot of what that emulator looked like. Now, the problem back then was that the XDK was not open. You had to have an hacked Xbox to even be able to write code for the Xbox, for the original Xbox. So the dream of releasing that emulator kind of died. But you will see the ZXbox return in a couple of minutes. So that is the origin of the name of the emulator. In 2002, .NET came out. I dove right into VB.NET and I'm like, oh yes, this is so cool. And I had a colleague that said, no. This is what we're going to do. We are going to focus on C#. And I'm like, what? No. So we know VB, we know ASP, we are already set, we can do this, VB.NET, that's the thing. And they said, well, we've been developing in VB and ASP for a very, very long time. We have a lot of old habits. So what we're going to do is we're going to learn something new. We're going to learn C# and not bring over all of those bad habits. That was a great advice. Now, around 2006, the first version of XNA came out. And now, suddenly, it was possible to create games for the Xbox 360. The idea popped back into my head. It's time. It is time to build an emulator in C#. So I went on eBay and I got this book. Now it's apparently completely transparent. The Programming the Z80 by Rodney Sachs. So I took the book, I turned the page, and I started implementing the first instruction. Before we do that, we need to kind of talk about what does it take. Now, if we just go back a bit and we talk about the different things a computer can do. Now, a CPU can do things. It can do operation codes or op codes. Basically, what it is, it's assembler instructions. Now, we're going to break this down into what that actually means, but in short, it's all about adding things, moving things in memory. Now, the ROM differs from different languages. For example, this is a Swedish ZX Spectrum, and it has the Swedish characters as well. The problem is that you're not allowed to distribute the ROM. And by not being able to distribute the ROM, you cannot distribute the emulator. That is why the emulation is often not allowed in the Microsoft Store, for example, or any other stores as well. Now, in 1986, Amstrad bought Sinclair. And they said, you know what? If you don't tamper with it, if you don't remove the Sinclair logo, you're fine. Distribute it. Which was amazing news for us that we're working with emulators, of course. So the ZX Spectrum has different registers. Now, this is starting to sound complicated, perhaps. Think about it as a byte. So it has A, F, B, C, D, E, H, L, and it has prime versions of those as well. Now, the cool thing with the ZX Spectrum was that you can take all these 8-bit registers and you could combine them into 16-bit registers. It also had one very special register, and that's the F register. It contains flags. So it contains the sign, the zero, the half carry, the parity, and so on. And so I started to think about how would I implement that register in the emulator. I had two options. I could go for a byte or I can go for bools. I ended up using bools for this because it was easier to set all of these things. Because in some instructions, you should set the half carry, for example. The sign bit is the most significant bit in the A register and so on. Now, this sounds all mathy, but it's actually very well documented. So the Programming the Z80 book contains all of these things, and we're going to come back to that in a bit. Now, there are also a bunch of other registers as well. I'm not going to go too deep into this, but we have the program counter, which points to a location in the memory. We have the SP, which is a stack pointer. We have IX and IY, which is index registers. And we have a couple of special registers as well. But we're not going to dive into those for this talk. Looking at how the registers were accessed, but we're going to come back to that in a minute, I realized that I could put them into an array. This was the absolutely easiest way to access the registers. This was not the first iteration, I might add. Why this is ints and not bytes, I cannot tell you why. Apparently, at some point during the development of the emulator, I decided that it should be ints. I'm probably going to turn that back to bytes very soon. I have no idea why. Then I have some nice properties, like this one, for example. So I can get the register, the A register, from just an A property. That's going to be a whole lot easier. And then I have the combined 16-bit versions as well. Now, I'm a self-taught developer, so all of this bit shifts and or operators, this was totally new for me, and something that I definitely not usually use when I develop. So it really keeps me on my toes. The program counter it points to a place in the memory, and whatever is in that memory position gets executed. Okay, so once it's done, it's going to move +1. So now we're pointing at position 2, which has the opcode 78. And let's look a little bit deeper into that one. The PC, the program counter, is pointing to 78. This is a binary representation of 78. Okay, so I wonder what that does. Well, the assembler instruction is LDAB. It loads the A register with the value from the B register. So basically what it says is that take the B variable and put it into the A variable. That's basically what that instruction would do. So let's bring out our trusty ZX80 book and let's take a look at what is actually happening here. So 01 followed by the destination register followed by the source register. That is where the 78 comes from. So when I wrote this presentation, I realized that, this can be optimized even more than I have. Now, if we look a little bit more, we will see that the book has some timing information. It takes 4 t-states, which we will come back to in a bit. We also have a matrix filled with opcodes. So we can see that the code 78 loads A with B. And we also see down here that the flags has no effect. We would not change any flags when we're doing this change. Okay, great. So we can see that the 78 is load A with the B register. Okay. Getting the value looks like this. We take the first 3 bits of the opcode. That is one of the registers. So if we take hex value 78, we put a bit mask of 7 there, which is going to leave us 0, 0, 0, 0. And if we go back to the book, we will see that 0, 0, 0 is the B register, right up here. Okay, so the opcode is apparently telling us all the things we need to know. Just to break it down, is that I could have duplicated this code 7 times for the source register, 7 times for the destination register, which would mean that I would have a kind of the same code 49 times. But the 78 opcode is doing exactly this. It puts the value from the B register into the A register, and it subtracts some timing. It takes a little bit of time to do that. So instead, what we could do is we can use the method I just showed you to get the value out of the register. So now I can have all these cases controlled by the same method. Great. Now, this was what it looked like until I wrote this presentation. Now, I used C#9 to use these kinds of statements instead. So I'm going to be able to say that if it's equals or larger than 78 or less or equal to 7D or 7F. So the tricky part is that 7E is something completely different. So now I can use this, I can write it like this, but I still need to do it 7 times. Based on the documentation, I had the source registers and I had the destination registers as well. So I could take that code and I could rewrite it to look something like this instead. So now I'm handling all the sources, all the destinations. So what used to be about 80 lines of code is now reduced to 10. And this is why I love working with the emulator, because it's pushing the boundaries. When C#9 came out, I could rewrite it, get it. I don't know if it's actually easy to read, but it's less lines of code, which is fantastic. Looking at the different instructions, we have no prefix opcodes, which means basically that the 78 there is a no prefix. Then we have ED, which is a prefix that has 78 different opcodes. CD prefix has 256 different opcodes. The DD prefix has 85, and the DDCB has 256. So when you put all of this together, because there are some undocumented ones as well, you will land at about 1,000 different instructions. Let's talk about timing. The Z80 is running at 3.5 megahertz. It has 50 frames per second. That means that there are 69,888 T-states per frame update. That means that we have 20 milliseconds per frame update. So let's take a look at the memory. Now, first we have the ROM, followed by screen memory, followed by screen attributes. All of that we will come back to. We got the printer buffer, we got a little bit of system, we have got something reserved, and followed by some addressable chunk of memory. That's where we can do some really cool stuff. And it ends up with a little bit of system memory as well. Okay? Great. This memory is addressable through a 16-bit register. That's why we need to combine the two. So in total, we have 16 kilobytes of ROM, we have 48 of RAM, which gives us 65 kilobytes, which we can access using two 8-bit registers. The 120K Spectrum has the same amount of register or 16-bit registers. It can just swap out different chunks of memory. So they solved it that way. It's using memory banks to be able to address 128K, but still using only two 8-bit registers. The screen is 256 times 192. It has a border around it. In my case, the emulator has a setting that can say how much border it should have, because we don't want to fill the whole screen with borders. Now, I could not for the life of me get my head around how this screen was working back then. So I have a colleague, or I had a colleague, I should say, called Mats, and he helped me figure this out, how everything worked. It has two segments, the screen. It has pixels and color attributes. The pixel data is stored in a very interesting way. If you fill the memory with data from top to bottom, it looks something like this. So what is actually happening is that it's stored in lines, So it's going to get 1, 9, 2, 10, 3, 11, and so on. And it's stored in 3 different segments, top, middle, and bottom. Now this only gives us 1 pixel per bit. But what we also can do is that we can add attributes to these pixels, what color they should use. And I love the naming because it's named paper or ink. So I can set the color of the paper and the color of the ink. I just love how it's named. Now, doing a talk about the ZX Spectrum, I obviously need to spell it with a UK spelling because it's a UK computer. So the ZX Spectrum has 15 colors: black, blue, red, magenta, green, cyan, yellow, and white. And there's also a bright version of all of those colors. Now, black is the same in both colors, which leaves us with 15 colors. Or what I saw, 15 shades of gray. Now, the attributes are stored in memory, so it's 8 by 8 pixels. So you store the paper color and the ink color by 8 by 8. So you can only change the color in these 8 by 8 pixels. And you will see an example of that in just a bit. So we have 3 bits for the ink, 3 bits for the paper, 1 bit whether or not it should be bright or not, and 1 if it should blink. So it's switching between ink and paper. So let's take a look at what that would look like. Now, if we're loading, this is, by the way, one of my favorite games. So let's take a look at what it looks like when we're loading it. You can hear the wonderful sound of a ZX Spectrum loading. So as you can see here, now this is sped up a whole bunch. What you can see is that it's going 1, 9, 2, 10, 3, 11. 3 segments, top, middle, bottom. And then we're getting all of the colors when the attributes loads. And we also get the blinking, the flash with Jetpack loading. Some of the challenges has been converting hardware information to software. How do I even code hardware? What does it mean when they're saying, well, there is a resistor between the mic and the ear? So what does that mean in code? But it keeps me on my toes. I have to avoid the garbage collector because if that hits in those 20 milliseconds, we're going to get bad sound or choppy graphics. I'm using temp variables as fields so that the garbage collector doesn't destroy them at any point. So I'm not doing any unnecessary allocations. I'm working with bits, bit shift and all of the and or and all of those stuff, which is not something that I do for in my daily life as a developer. Now, tests are super important, of course. So what I did was that I took the fuse test, you remember the emulator, took all of those and I converted them into Visual Studio tests. So now I have an input state, I'm running it, and I'm checking against the output states. Which means that I dare to refactor. Because if the emulator if the tests are still hitting the same things, it's just gonna work. Around 2006, 2007, I got my first version running on Xbox 360. It had keyboard support, but at this point it didn't have any sound. Here are some more screenshots of what it looks like, or looked like, I should say. Now, someone released an emulator just before I was done, and I kind of lost interest again. In 2008, I had a horrible day at work. I came home close to 1 a.m. I was super tired. But that day, a new version of XNA had dropped. A version where you can deploy your XNA games too soon. So Jessica, my wife, came into the home office and said, "Are you still working?" And I'm not. Yes. What are you doing? Okay, a new version of XNA just released today, and I just needed to see if it worked with my emulator. I could run it on my Zune. And soon after, pun intended, I actually got it working. Sadly, it was a little bit slow, but it did work. Now, this was one of the things that Jessica used to send to Microsoft Tech Days to nominate me as Geek of the Year a couple of years later. In 2011, I went to my first conference, Tech Days, and I received my prize as Geek of the Year. This has opened a lot of doors for me. Suddenly, Microsoft Sweden knew who I was. And the latest, the same day, I was demoing my Windows Phone app, Stockholm Travel, at Microsoft headquarters in Sweden. And one of the speakers, he said, Jimmy, you gotta show them the emulator. And I'm, yeah, sure, I can do that. So I'm ending my presentation with showing the emulator. And I got the first and only spontaneous applaud of the whole day. That felt so good. And I really felt the love in the room. So that made me think, maybe public speaking is a thing. Maybe I should give that a shot. In 2011, I think it was 2011, 2012, I was contacted by a UK company called Elite. And they own the rights to hundreds of Spectrum games. So they said, so we saw that you have a Windows Phone emulator or a ZX Spectrum emulator for Windows Phone. Could you get Manic Miner running? Now, at that point, the sound was still a little bit off. So I exported Excel data and compared the data back and forth, and I actually got the sound to work finally. In 2012, Manic Miner was released for Windows Phone. I spent a lot of time working on the emulator, getting it to work on Windows 8. I even ported it to C++ at some point to get it running on Windows RT computers. Now, Elite even hired me to get 108 different games out on Windows 8. Around 2012, the Xbox opened their indie program. So they allowed games onto the store. Now, that was a very interesting process. The people that tested the games was peers. So it was other developers that tested the emulator. And they were like, yeah, so if I yank out the cable for the controller mid-load, it broke. Yeah, and I did not test for that. Elite asked me to do Manic Miner and Chucky Egg as well. So there was a couple of different versions of the emulator running on Xbox. I've been traveling all around the world, speaking at different conferences, and we started a podcast to share all of these meetings, meeting with speakers, meeting with attendees. So we have a user group, a podcast, a Twitch, or even a YouTube channel where we share all of these things. So if you're interested, check out Coding After Work. Now I asked a friend of mine to make an intro. So we asked, well, what kind of things do you want? I said, well, I obviously want vocoders because I love vocoders. And he knew that I loved Kraftwerk. He knew that I love Depeche Mode and especially the Speak and Spell era. And he added a little piece of a surprise in there as well. The CODING part of the intro was recorded from a Chorus microspeech. So that was a speech synthesizer on the ZX Spectrum. And I remember I had one of those and I sat down and I could just go J, J, I, M, 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 Y. And I just thought it was so cool making the computer talk. Then the HoloLens came out. The HoloLens is just an amazing device. So I rewrote everything with Unity, but using the same C# backend. So this is the emulator running inside of HoloLens, which is kind of cool. And this is my favorite game, Jetpack. Just give it a little bit of a moment in here. You can see it's flying around and it's on a holographic TV. This brings us to Blazor. When Blazor first came out, we just finished a delivery. We were just days from putting it in production. And I showed my colleague, hey, I just want to show you this. I think it was a select box or something like that. I just showed him and he was like, we're doing this. This is what we're going to do. This is the feature that we've been waiting for. So 7 days later, we were running it in production. Being a fan of Blazor, I wrote a book about Blazor. The second edition just came out. And this is the only Blazor book that has raccoons on the cover. But this leads us into the more Blazor specific things in the implementation. One of the really fun things with building an emulator is that it's really pushing the boundaries. It's touching a lot of different technologies. So to get sound working, I'm using JavaScript interrupts, and they need to be really, really fast. So I'm using the audio context. I'm sending bytes from C# over to JavaScript, queuing them up, queuing up 20 milliseconds every 20 milliseconds to get the sound working. Keyboard support is using JavaScript, and it needs to be platform specific. So it's saving the keys, the different keys that I press into an array, and then the C# code is making an interrupt, getting those values from the keyboard, what buttons are pressed right now, getting them back and acting on it. So this is how the ZX Spectrum works. It checks the keyboard in different intervals. When it comes to the screen, we have 256 pixels plus the border. We have 192 plus the border. And we're going to take those values times 3 because we got RGB. This gives us 200,000 bytes. And pushing all of those bytes over interrupts was way too slow when I built this the first time. So what I did was that I allocated some memory. I got the address of that memory, and I'm calling the JavaScript using a pointer to that memory, and then I'm freeing that up. So on the JavaScript side, basically what I'm getting is that I'm getting those bytes directly from that shared memory, which I think is really, really cool that you can do those kinds of things. At this point, running the emulator was slow. It's running around 10,000 assembler instructions. It's generating 20 milliseconds of sound, pushing that over to JavaScript. It decodes and shares the screen and paints the screen, and all of that in less than 20 milliseconds. Again, pushing the technology. In .NET 6, we got AOT, ahead of time compilation. So it's going to take all of that C# code and convert that to WebAssembly. WebAssembly is way faster. The problem is that the file size gets a lot larger as well. But let's take a look at a demo. So if you want to try this yourself, zxbox.com, and you can try it out. Here is the ZXbox webpage. It's running .NET 7. It's running ahead of time compiled. And if I reload this page, you'll see that it loads fairly quick. To be fair, it is cached at this point. Let's just start the emulator here. You'll see that it starts, and I can even load a game. And if I turn on the sound, you will hear the sound working as well. And here I can play the game, do stuff. Well, you can try it yourself. As you have seen, I have made Manic Miner for many different platforms. I have spent hours testing it, getting it to work, trying to beat the first level of Manic Miner. I have still not to this day been able to beat the first level. So if you do, please let me know. I'm pretty sure you can't even beat it. I actually have a colleague that sometimes calls me up on Teams and he says, Jimmy, you got to check this out. Oh, I'm intrigued. What is it? And he shares his screen showing me how to finish just the last seconds of the first level. See, it can be beat. So what does the future hold? Well, I would love to be able to implement the car microspeech. The next thing I think I will do, though, is to implement the printer. Now, I never had one of these printers. My brother had one. And it has an aluminum foil that gets burnt. So it had a very, very special smell. And I think that the implementation of this should be fairly easy to do. Not the smell, but the printing. So that is one of the things that I would really love to do. So the ZX Spectrum is the reason I decided that I wanted to become a developer. It's the reason that I became a developer, which is the reason that I met my wife. It's the reason I became a public speaker, an MVP, got to travel the world and be here and talk to you. So thank you so much for being part of my journey. And please reach out. Let me know what you do with Blazor. Let me know if you finished the first level. Let me know if you liked this presentation or if you have any suggestions for the next one. Thank you so much.